Hello and welcome to this tutorial on multiple linear regression from Analytics School Online. We are finally here in the second part of this series of multiple linear regression. We've already covered the theoretical concepts which actually told us what are the various bumps that we might face and their solutions. And finally we are here in the practice session in the second part where we are going to analyze our data with Microsoft Excel. It's going to be super fun and super easy. I'm very excited to share this with you, and just keep in mind that just giving a little focus to what you're going to see after this, you're going to love it and you're going to actually implement all of these for the rest of your life in your careers as a data analyst. And we're going to get to the third part, the analysis section of this series, but sure is a little time later. Moving on. Now let me tell you the three integral parts of practicing or implementing the multiple linear regression model. Well, when we were trying to implement the simple linear regression model, it was actually very simple and we did not have to actually handle missing datas or do various of the data pre-processing parts. We did not have to actually analyze or keep comparing our models again and again because it was just one independent variable. But here in multiple linear regression, it's very different. The first thing that we need to follow is actually we need to pre-process our data. Now pre-processing is very important. It's very crucial for actually analytics, and data analysts have always tried to be better at data pre-processing, because after data pre-processing it's really easy and very efficient to implement analytics. So in data pre-processing we are going to do three things. We are going to handle missing values, we are going to take care of the categorical variables, and we are actually going to eliminate the useless values, the useless columns which actually do not hold any importance. In the second stage we are going to compare the p-values, the p-parameter of our data set to a significance level of 95%. So a significance level of 95% actually means a p-value of 0.05. So we are going to compare all our p-values with 0.05 and finally improve our model, and we are going to reassure our accuracy of the model by adjusted r-squared every single time we change the p-values. And finally we are going to use elimination and inclusion of combinations of variables to get to a better data set. And this is going to be the part 3 of this video series, the analysis of our analysis, where we are actually going to compare the summary outputs that we've obtained in the analysis section here in the data analysis part in Excel, and then finally we are going to create our model equation. That was it for now. Let me just remind you about a few things where various data analytics models or models such as simple linear and multiple linear regression, which we are implementing in Excel, are already very easy to implement in other libraries and in other languages such as Python, R, Octave and some other stats models. But I'm just trying to show this to you in Excel because it's very simple and easy to understand, and it's good for you as a beginner to get brief but in-depth idea of the concepts which you actually need right now. So let's proceed with the Excel data pre-processing part now, and we'll get to the data analysis in the next video. So here we are in a brand new Excel sheet where we have already imported our data so that we don't waste time any further. And just to remind you, just make sure that you have the data analysis toolkit already installed. If not, you can simply go to File, Options, and get this from the add-ins section and simply install the analysis tool pack, which would be right here somewhere if you've not already installed it, and once you've done, it is going to appear here. So now finally moving forward, the first step of analyzing any form of data or analyzing any data set is to pre-process the data. Now data pre-processing, as I mentioned earlier in the first part of the video, is one of the most important aspects of data analytics. It is this where we actually try to create a highly efficient data set for our process. Now data is basically available in raw formats where you'll not actually have these headers, you'll only have a description of the data. You'll have data in various formats, like you can see the categorical variables, even the numerical variables are actually written in categorical form. We're going to change this, we're going to convert this using functions, and you'll get these indexes, brand names and various other columns, which is basically raw data set. Now you have to try to arrange and organize these data sets, well, name them properly and then align them in a certain fashion so that the numerical parts come right over here and the categorical variables come over here, and then you have to keep your dependent variable to the extreme right because it is the only one we need to access always, and it should be in one column only. And so Let's begin with data pre-processing. Now once you start analyzing the data, the first thing that you're going to notice, I guess, should be the missing values. As you can see, this cell is containing a question mark, a question mark, and a question mark. So this is basically a missing value. Now there are many ways to actually remove the missing value situation and deal with them, but what we are going to do here is actually we are going to take average or a mean of the values in this column and replace this missing value with that mean. So let me show you how easy it is to implement in Excel. You simply click on this cell, go to the functions area, and you type equals average. There are many functions already available in Excel. You can simply scroll down and get the average function. Once you get the average function, you double click on it. So now what do you want to do? We want to actually replace this missing value. We want to actually replace this missing value with the mean value of all the values of this column. Now just to give you a brief heads up, if you try to select this column altogether, you're going to get an error because the function average is actually going to call this cell as a part of the column, and it's going to give you an error that you are trying to call a function within a function, which is not possible. What you should do is that you should select this part, then press Ctrl and again select this part. You can see it is appearing in different colors. So basically it defines that these are two different sets of values, and you can simply drag this down and select it, and once you go back up, you're going to see that both of these sections of the column weight has been selected, and you can go here, you can complete the parenthesis, and you can press enter. So here it is, we have replaced our missing value with the mean value of the whole column. Now moving forward, we can do the same for these. We can simply type is average and we can select our first part of the column. Moving on, we are going to press Control. Remember to always press Control, because if you don't press Control, Excel will actually understand that you are trying to select another column and you are not interested in this anymore. So basically this will be removed and the Excel will again start calculating from this column. So you must always remember to press Control and then select the other part of the column, and once you complete your parenthesis, you simply press enter, and here it is, you have your value for average. And we do the same here, and we get the values and we get the mean value, and we press enter, and you can see this value has been replaced by the mean value of different sets of this data set. Now what you can actually do is that if you're already having like we considered the example here of only one missing data, if there are 2 to 3 rows of missing data, you can actually try to start with any random missing data value, and you can select all the parts of this column except the missing values by simply pressing Control again and again and selecting those sets, and then this will be replaced by the mean values of the values available presently. And as soon as you move forward, you can select the values which have already been transformed from missing to the mean values, and this is the way how you actually deal with missing data. Now once you've dealt with missing data, the other part is to actually convert these kinds of categorical variables where the variable is actually not categorical but it is written in the form of categorical variables. As you can see, you can simply write 4 here if you want to. You can replace 4, you can replace 6 here, and then again 4 here, 5, 5, but that's pretty meaningless, right? So let's learn how to actually do this in a very simple way, because we are actually having too many rows to simply write every numerical value for each and every one of them. So what you try to do is that you create another column of cylinders here. Once you create that column, you actually try to create a function which can convert this value to a numerical 4, this value to a numerical 6, and this value to a numerical 5. So what you have to do is that you have to create a function, and in that function we are going to use the if else statement. From the if else statement we can simply convert all of these unique values to their numerical counterparts. Now how do we do it? First we need to understand how many unique variables are there. Like we can see 4, 6, 5, then 3 is here, then you get 12, so 12 is another variable, then you have 8, and finally we have, okay, so we have 5 such different unique categories in the cylinders column. So what we try to do is that we are going to select this, and in the functions bar, let me show you how easy it is. We press equals. Sign tells Excel that we are trying to create a function, so we press if, and then as you can see, the if function already tells you what it is capable of doing. It first takes the parameter of logical test, the test of, you can use the logical test being a comparative test or a equal to test, and once you use this test you hit comma, and then you press the value, or then you enter the value which you want to replace this column with once this condition logical test is true, and the value which you should replace if this logical test is not true. So what we are trying to do is that we are going to select the logical test. We are going to press 4, and we are going to type equals, and in double quotes we are going to type the letter 4, and then we are going to replace this value by numerical 4. Now if you are trying to actually create one simple if loop, you're going to simply input the value which you need to replace if it is true, and then the value which you need to replace if it's false. But if you're trying to create nested if loops, so basically you can only replace all the values of falsity. If there is a false condition, you can replace this value with one value which you are actually going to input in the end. So let me show you what we are trying to do here. After this statement, we actually try to create another nested statement which would again call if, and again create a condition with the same row. I'll tell you why we are selecting the same row again and again. It's because we are going to drag it along for the whole column and actually make our program even simpler. And just like before, we've input the value which we need to replace if the condition is true, and again we create another nested loop condition where we again select this row, and I'm going to do this for you. So I just fast forward the video because it is actually the same. So finally we are here. We've created our 6 nested loops in the if condition because we had 6 unique categorical variables. And once we are done with this, what we now need to do is that we are going to input the value which Excel will replace in our column if the conditions are untrue individually. So let me replace that with 0, the value which we need to replace if our conditions is false. And finally we need to close our parenthesis, and Excel actually blinks with every parenthesis, the parenthesis it relates to. And you can see here that we had 6 nested loops, and in the end we have had 6 brackets. So that is a way to track your function. And if in any part of this function you actually commit some mistake, if you miss a comma or if you miss a double quotes, this G5 cell will actually not appear in blue. It is going to appear in some other color, indicating you that there is some mistake in your function creation. So that's it. Once you've done this, you can simply press enter, and you can see our result here. Excel has actually replaced 4 once for the row where there was 4. And why I asked you to select this cell again and again is that now we can make our task easier by simply dragging this column to all the rows of our data set, and that makes it easier. And want to see some magic? Here it is. Now you have replaced all the categorical variables which were actually in alphabetic form to your numerical form by just using a function. So that was another part of data preprocessing, to create your data or to manage your data in such a way that regression can actually understand it. And now once you do this, you're going to simply need to actually create this cylinders bar, and you can do the same for your seats column, and that's it. So you have to actually create another seats and cylinders column. Now I'm not showing this right here. We'll simply proceed with both of them in the next video, because it just wastes our time. We've understood the logic and we can implement it ourselves, and that I'm leaving up to you for practice. Moving on, now we actually do not need this index column. We're actually going to delete this column, because index does not hold any significance when you are implementing a regression model. So you simply delete this. You can see all your columns have been shifted towards the left. Now to deal with categorical variables, you must also keep one thing in mind. Let me just tell you this. If you are actually observing a column which has almost the same values for more than 70 to 80% of the times, like this column which you can see here, out of 200 or 250 values, the fuel column has almost, as you can see, only gas as an input. There are a few diesel columns, as you can see here, but there are not that many as compared to the gas. So we can assume that 70 to 80% of the values or rows in this column have gas as input. So I'm not saying it's totally unimportant. It does hold significance, but presently we are trying to implement a more simple or more easy to understand multiple linear regression model. And once we get advanced in this, we are actually going to take every single column and try to evaluate their importance. But if we actually try to use all these columns and create so many combinations, our job is going to get difficult and the video is going to be pretty long, which is eventually going to bore you. So I'm also deleting this column, but I told you the logic and I told you the repercussions of this. So you're going to convert the seats column. The cylinders column has already been converted, so you don't need to worry. This body column now needs to be actually changed. So we are going to deal with the body column as its categorical variable, and we are going to try to avoid the dummy variable trap with this. Now we can do this with the brand column also, but it's going to take a lot of code because the inputs are of various names, and the intensity or basically the unique values would be a lot, so it is going to get a little complicated. So I'm not trying to make the video boring for you. So we'll try to convert this body categorical column into the numerical column. So the first step, we must analyze how many unique values are there. So you can see convertible, hatchback, sedan, and then wagon, and then there is again a wagon. We don't see any more unique values. Now here it is another unique value of hard top, and I guess that's it. Moving, just doing some checking so that we do not miss a value. And finally we have 5 different unique values. So what we do here is that we exactly name these columns after the names of the unique variables. So what we are going to do is that we are going to type hatchback here, then we are moving to the next column. We are going to create these 5 columns, and those are going to be so done with them. We had 5 unique values in our body column, and we have created 5 different columns for using them. So now what you need to do is you need to again implement a function. Now with Excel, I'm trying to persuade you to use functions because it makes your task really easy. It makes it just do the task in a blink of a second, only if you implement it the right way. So let me tell you how to implement in the right way. You select the cell in which you actually want to implement it, and once you select the cell, you actually create an if-else condition where you type equals, which tells Excel that it's a function, if you select this body cell, and then you actually try to compare this with the column you've named it for. then you basically give the value which you must replace it with once this comparison or this logical test is true. So we're going to put 1, and for falsity we are going to put 0. And now the interesting part is you can do this for this column individually, then again for this column, and the 5 other columns, but we are trying to make our work easier. We're going to process data very fast. So what we need to do is that we need to change some parameters which can actually help us and make our task really easy. So what we do is that we fix the body column first of all. So body column is the D column. The row is not fixed because we are going to need all these rows, but the body D column is fixed. So what we try to do is that we put a $sign. You can do that right here or here, doesn't matter. It's going to actually create the same function. So you must put a $sign before D, which tells Excel that this column D is actually a fixed value. And moving forward, once you move ahead, what you need to do is that you need to also fixate or create a constant value for this column of 4, because we are going to actually drag this selection towards the right and then drag it towards the bottom, so that we can actually create all of these at the same time. So we are going to put a $sign at the 4th row, because first we are going to implement this over here. And once we are done with this, you can simply press enter, and you can see that our first variable was convertible, so hatchback gets a 0. But once you drag this towards the right and select for all of your unique variables, you will see that convertible gets a 1, since body column's first row was convertible, so convertible gets a 1. And now finally the interesting part, what we try to do is that we do this and we hold it right here. We get this sign, a plus sign, and we drag it along for all our rows. And again, want to see magic? Here it is. So what you now have is the simplest data pre-processing miracle, where you have actually divided your categorical variable into 5 unique columns of your categorical variable already. And now, to avoid the dummy variable trap, to solve the problem of dummy variable trap, as you know from your theory part, you actually need to subtract 1 feature out of the total 5 unique features that you have now made. So I guess hard top was very rare. So what we try to do is that we delete this column. So you can go at the column name and you can simply press delete, and here it is. Now let me tell you, if you try to actually delete this column, the body column, all of these are going to be regged, because these columns are created on the basis of a reference to this column. So these are not going to work if you actually do not have this body column. You can actually try that along. So if you try to delete this column, you can see that there is a reference error in all these columns. So I'm going to press Ctrl Z to undo my action, and finally I have them back. Now just to make your data a little more organized, we are going to shift these rows, the rows we are actually going to need. After converting the seats and this we've already converted, so we are going to convert this for engine also, because it's standard and turbo, and basically there are only 2 types of engines. So we are going to simply replace one with standard and turbo with 0. And we are going to finally proceed with our data set, as we have converted all our data values into basically numerical values, and now we can use multiple linear regression. And so that was the end of data pre-processing. We've tried to give you a brief idea of how to pre-process data, and you're going to need these steps whenever you implement any model in Excel. It's really easy and it's really important. You just need to keep a few things in mind. So meet you back again in the implementation of the linear regression model. We are going to put our values, our data in the regression model, and I'm going to see you again in the next video. Until then, take care. Thank you.